Okay, now let's look at your Chapter 10 exam review problems, numbers 13 through 15. Starting with number 13, we have an angle. It's an acute angle, part of a right triangle, and they give us the ratio for cosine, and they want the sine and the tangent. The trick on this problem is that you need to draw a triangle. So just draw a right triangle and mark one of the two acute angles as your theta. Don't mark the other angle, just mark one of them. And then label the sides as to how they relate to that angle. We have the hypotenuse. It's opposite the right angle. It's the longest side, probably the slanted side. Then my vertical side here is adjacent because it's right beside the theta that I marked. And then the horizontal side is opposite. It's across from the angle that I marked. You're also going to be able to fill in numbers for two of the sides using this cosine fraction. So cosine I know is adjacent over hypotenuse. So I'm going to mark the adjacent side with a 7 and the hypotenuse with a 25. Then you need to find the third side, the one that does not have a number that you filled in. And the way that we're going to find that is with the Pythagorean theorem. I'm trying to find the opposite side, which is one of the legs. So I need to leave either the A or the B in the Pythagorean theorem there and fill in the A and the C, or the B and the C, with the two numbers. So I'm going to put 7 in for A and be solving for B. The 25 needs to go in for the C. So you could have put the 7 for the A or the B. It's important that 25 be the C because C is always the hypotenuse. Now to solve for B in this equation, I would need to subtract 7 squared from both sides and then take the square root of both sides. So in my calculator, I can put in square root symbol, 25 squared minus 7 squared, and you'll get 24. All right, so that I'm going to fill in now as my opposite side, the one that I didn't know. Okay, so our steps so far in this problem: draw a triangle, mark the sides using the hypotenuse, adjacent, and opposite, and then fill in the numbers for two of those sides using the fraction that they gave you. And then the next step was to find the third side with the Pythagorean theorem. Now we can finally write out our answers. Your answers for tangent and sine are going to be two more fractions. They're going to look very similar to what you were given, which is a fraction, using the numbers that we filled in here. So sine of theta is opposite over hypotenuse. That's 24 over 25. Tangent is opposite over adjacent. That's 24 over 7. Number 14 says to use our calculator to find the cotangent of 83.7. So this will be pretty simple since we can use our calculator, as long as we remember what cotangent is. Cotangent is the reciprocal of tangent. Reciprocal means that it could be written as a fraction with tangent in the denominator, and that's how it should look when we plug it into our calculator. 1 over tangent, and then you put in 83.7. It is not the second function of the tangent button, which will look like that. That means the inverse of tangent on your calculator. It does not mean reciprocal. And if you punch that in and it gives you an answer, it'll be the wrong answer. Sometimes you're lucky enough to punch that in and it tells you that there's some sort of error, which is a good indication that you've done something wrong. You need to write it as a reciprocal 1 over tangent. And it might not be cotangent, it might be secant or cosecant, so you need to remember which functions those are reciprocals of. In your calculator, if you put in 1 over tangent 83.7, and we're going to round to 4 decimal places, it would be 0.1104. Real quick review of the other two, just in case they come up. Cosecant would be 1 over sine of whatever angle they give you, and secant is 1 over cosine. All right, Number 15 asks us to solve for the triangle RST. If it asks you to solve for a triangle, you need 3 answers. It's going to be an angle and 2 sides, or a side and 2 angles. It's going to be 3 parts of the triangle that aren't marked. So I have 3 parts that are marked right now. I have the hypotenuse that's marked with a 15. I have this angle R that's marked as 72 degrees. And I actually have a third thing that's marked, even though I don't have a third number, and that's the right angle. I know that that one's 90 degrees. So the 3 things that I don't know are this angle S. I need to figure that one out. Also the little side S and the little side R, or the side little s and the side little r. Anyway, those are the 3 things that I need to find, and they'll be my 3 answers. To find the angle S, all I need to do is, since I'm given the other angle, the other acute angle, I just need to subtract that acute angle, 72 degrees, from 90 degrees, because the 2 little angles in a right triangle always add up to 90 degrees. So 90 minus 72 is 18 degrees, and there's my first answer. To find the sides, S and R, I'm going to mark them as to how they relate to the angle. I'm going to focus on that 72 degree angle the whole time. So side S is adjacent to it, and side R is opposite. And I already marked the 15 as the hypotenuse, so I'm going to be using that. Then focus on one of the sides at a time, along with the side that has a number marked with it. So if I focus on side S, it's adjacent, and I know the hypotenuse. So I'm going to think of the trigonometric function that involves adjacent and hypotenuse, and that's cosine. Then I'm going to go over here and write a function that has cosine in it. I'll put the angle that I was looking at after the cosine or sine, whatever I could come up with, and then set it equal to a fraction, and that fraction will be adjacent over hypotenuse, but I'll fill in what the adjacent and hypotenuse are. That's S over 15. Then you need to look at your equation and try to solve for that letter. A side note, since the angle is not one of the special angles, 30, 60, or 45, you can use your calculator. So let's solve for the letter, and then we'll have something we can plug into our calculator. Since the letter I'm trying to solve for, S, is in the numerator, the only thing I need to do to solve for it is to multiply both sides by 15. So that means S is equal to 15 times cosine 72, and I can put it into my calculator just like that, 15 times cosine 72. And you should round your answer to the 10th place. So I'm looking at my calculator, I'll round the answer to 4.6. That's my S. Then I'm going to focus on the other, I'm going to not look at S now and focus on the other side that I'm trying to find, R, and the side that has a number, 15, that's opposite and hypotenuse. And I want to think of the trigonometric function that involves opposite and hypotenuse, and that's sine. Put the 72, the whatever the degree number is after the sine or cosine tangent, whatever you came up with, set it equal to a fraction, and then put those 2 pieces in the fraction. Opposite over hypotenuse would look like R over 15. And once again, I have the letter that I'm trying to find, R, in the numerator. So to solve for it, all I need to do is multiply both sides by 15, and I can put in my calculator 15 times sine 72, round it to the 10th place, and I get 14.3. Real quick, it didn't happen in this problem, but if you end up with something like, just making things up here, tangent 38 equals 5 over x, and I'm trying to solve for an x, or any letter, whatever letter, if it ends up in the denominator of the fraction that you set up, then to solve for it, Cliff Notes version of what happens is that not just the 38, but the whole trigonometric function with its angle and the letter switch places. So you can rewrite it as the letter, in this case x, equals 5 divided by whatever trig function you had. And you put it into your calculator like that. All right, that's it for 13 through 15.